All right, my dudes, I've noticed that a lot of you guys struggle with converting between units. So I want to do an example question and I'll walk you through the steps of what I would imagine would be probably the easiest way to do it. It's not the shortest way, but it's easiest in terms of conceptually. So you've got a question here. You've got decane, blah, 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 alternative to biodiesel, one major, da, da, da. One major component of the biodiesel is this guy here, requires you to investigate, blah, 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 blah. So you've got two thermochem equations, as you can see here, one for decane and one for the methyl hexadecanoate. The first thing we want to do is to actually convert the energy content to go to megajoules per kilogram for decane. So really we're worried about this particular reaction at the start. You'll notice that the units that have been presented to you for the delta H is currently kilojoules. Now, kilojoules per what? It's going to be kilojoules per mole, specifically kilojoules per 2 mole. So at the moment, the enthalpy, right? What you've got at the moment is 13548 kilojoules per every 2 mole. And the reason why I say per 2 mole is because as per the balanced equation, you're using 2 moles of the fuel, which is the decane, and therefore it's that. Now, what you want to do is to be able to convert it to something megajoules per kilogram. So you notice that there are two completely different unit sets. For energy values, it's kilojoules and megajoules. For whatever's at the bottom of the denominator, it's like moles and kilograms. So another way I want you to think about expressing this is as a fraction. So this here is the same as saying 13548 kilojoules per 2 mole. And then you're trying to find how much energy per, and because it's per kilogram, we're talking about per 1 kilo. So your job is to be able to slowly convert each of those units so they're identical so you can actually find the energy content. You'll notice what we probably want to do first here is to convert, so you can see how kilojoules, megajoules, and the second set that you need to convert is the moles and kilograms. Now it's probably easiest to convert from the unit that you have to the target unit. So first step here would be going from kilojoules to megajoules. I might just number this, so 1 and then 2, and then you do the calculation for the energy later. Okay, so the first thing I want to do is to convert that 13,548 into megajoules. Now in order to do that, so 13,548 divided by 1,000 will give you this many megajoules, right? So another way of expressing this is to say 13.548 divided by, sorry, that's megajoules, divided by 2 moles. I don't know how many megajoules here per 1 kilogram. So that was our first step, converting the kilojoules to megajoules. Sweet. So now we've got the two top units are the same, which is amazing. Let's do the bottom two now. For the second one, what I want to do is I want to convert the 2 moles into kilograms. So we see how we're doing it just one step at a time. So what's 2 mole? So 2 mole equals mass over molar mass. Now the molar mass of decane should be, what's that, 120, 142. So 2 moles equals mass over 142. So the mass then should be 284 grams. And converting that to kilograms, it'd be 0.284 kilograms. Okay, great. So now let's put that into our relationship at the top. And now we can express it as this. Oh, sorry about that. Per kilogram equals megajoules per 1 kilo. So you can see how now you've got the units that are consistent, right? At this point, the only thing you're looking for is you're trying to find the X, and that is the energy expressed per kilogram. I've taught you guys before, when you make the relationships like this, it makes your life really easy because all you need to do now is to cross multiply to find X, or just find X as if I was to give you this equation in a maths classroom, right? So now what we're trying to do here is this, which is the final conversion. And we're literally just solving for X. So if we cross multiply here, we've got this as 0.284x equals 13.548, because I've multiplied the 1 and that. Now if we do that, so 13.548 divided by 0.284, so 47.7. Amazing. So X equals 47.7 megajoules. Okay, so now let's just express it in the final answer that they want it in megajoules per kilo. So you insert that number in, therefore the delta H equals 47.7 megajoules per kilogram. Okay, so I know that it's long and cumbersome, and there will be shortcuts to be able to do later on when you actually understand conceptually what you're doing. But I think the easiest way to think about it if you're struggling is to start converting the units one at a time. Because what you want to do is to make the units consistent so you actually compare and make it proportional, and therefore find x later. So it's step by step. Just take one thing at a time until you get to the very end. Hope that helps.